Hello there, and welcome to a video where you'll master the complete use of APIs and API testing. APIs have become the center of software development, connecting and transferring data to millions of applications every day. By the end of this video, you'll fully understand the concepts like APIs, REST, CRUD, and API testing. That's a lot of acronyms, I know. But don't worry, the goal of this video is to explain these concepts without any jargon and straight to the point. In this video, you'll learn what an API is and how to create and deploy your APIs. You'll also learn about the concepts of REST and CRUD. And finally, we're going to pick a few publicly available APIs and do some API testing. Alongside this video, I've also prepared a complete guide to APIs and a cheat sheet that covers everything you need to know about APIs. You can use it as an ebook for learning or as a reference that you can revisit anytime you want to recall specific information about APIs. The guide covers everything from simple explanations of all concepts that I'll mention in this video, as well as the most common HTTP status codes and, more importantly, a list of popular APIs that you can use to improve your applications. You can pause this video, click the link in the description to download the resource, and then we can jump straight into the video. In this video, we're going to learn how to use PAW. PAW is a full-featured HTTP client that lets you test and describe your APIs. In here, they say it's the most advanced API tool for Mac, but don't worry, they have a web version that is completely free that I'm going to teach you how to use. And most importantly, that web version is available for all operating systems. On top of that, you're going to learn everything you need to know about APIs. And for that, we're going to use Rapid API Learn. They offer interactive lessons where you'll be able to learn through actually testing the data. You can see how API requests are made and how they return the data. I'll try to use this resource as much as possible throughout this entire video, but the link is going to be down in the description, so I would strongly encourage you to check it out yourself. With that said, let's go ahead and get started. Let's start from the beginning. What is an API? API stands for Application Programming Interface, and it allows two applications to talk to each other. Each time you use an app like Facebook, send an instant message, or check the weather on your phone, you're using an API. So, what exactly is an API? When you use an app, the application connects to the internet and sends the data back to the server. The server retrieves that data, performs the necessary action, and sends it back to your phone or computer. The application then gets that data and presents you with the information you want in a readable format. And that's what an API is. For example, imagine that you're building a trading platform. You'll need to support various features like exchange of currency, fluctuation of market rates, authentication, payment processing, and much more. Building and maintaining such functionalities is difficult. To resolve these issues, you can use integrations with various other software via APIs. To explain this better, let's take a familiar example. Imagine you're sitting at a table in your favorite restaurant with a plenty of choices to order from. The kitchen is the part of the system that will prepare your order. What is missing is the critical link to communicate your order to the kitchen and deliver your food back to your table. And that's where the waiter or the API comes in. The waiter is the messenger or API that takes your request or order and tells the kitchen, the system, what to do. Then the waiter delivers the response back to you. In this case, it is the food. This is an example that everyone uses when explaining APIs. But here on JavaScript Mastery, I strongly believe that you learn best while doing. In one of the previous videos, I've shown you how to build your API from scratch. Feel free to pause this video and add the build and sell an API to your watch list. Once you watch this video, you can then check that video out and everything is going to make sense. The link is going to be down in the description. So what exactly did I mean when I told you that on JavaScript Mastery, we explain everything with real-world examples? Well, later in this video, we're going to do some API testing and really try to see what the APIs are made of. How do they respond to certain HTTP verbs or actions? And what HTTP codes do they give back? In what format do they send and receive the data? And so on. Everything is going to be explained in depth in this video. Before we actually check that out, let's talk a bit about security. You're accessing all web applications through some sort of a device. It can be a phone or a desktop PC. Let's say you're using your phone to get to a specific application. Your phone's data is never fully exposed to the server, and likewise, the server is never fully exposed to your phone. Instead, each communicates with small data packets, sharing only what is necessary, like ordering a takeout. You tell the restaurant what you would like to eat, and then they tell you what they need in return, and then in the end, you get your meal. More recently, APIs became even more secure. Right now, most of the APIs are adhering to standards, typically HTTP and REST standards, that are developer-friendly, easily accessible, and are understood broadly. Of course, since everything is much more standardized, it means that it is that much more secure. REST, or Representational State Transfer, is a standard that web applications use to simplify the communication with each other. APIs that follow the REST principles are called RESTful APIs. The main characteristic is the separation between the client and the server. In the REST architecture, the implementation of the client and the implementation of the server can be done independently without each knowing about the other. This means that the code on the client side can be changed at any time without affecting the operation of the server, and the code on the server side can be changed without affecting the operation of the client. By using a REST API, different clients or computers hit the same REST endpoints, perform the same actions, and receive the same responses. Systems that follow the REST principles are stateless, meaning that the server does not know anything about what state the client is in, and vice versa. In the REST architecture, clients send requests to retrieve or modify resources, and servers send responses to those requests. And all of these requests follow the same structure. An API request has to have an endpoint, meaning the URL that we are requesting for. For example, whenever you go to a specific URL, you're basically just making a GET request to get that specific website. And in this case, the endpoint is rapidapi.com/learn. Your API request also has to have a method, meaning the type of the request we're making. In this case, let's say we're making a POST request, meaning we want to send some data over using that request. An API request also has headers, additional information for either the client or the server. In this case, that can be some information about the body. And finally, the body itself is the information sent to the server. Let's say that we want to create a new user with the name John Doe. This was the anatomy of an API request. Right now, we're going to take a look at the different methods that we can make. POST is just one of them. Let's take a look at the standard ways to make requests and send responses. To talk about that, we have to mention yet another acronym, CRUD, C-R-U-D. In a REST environment, CRUD often corresponds to the HTTP methods POST, GET, PUT, and DELETE. CRUD stands for Create, Read, Update, and Delete. And as you can see, POST is for Create, GET is for Read, PUT is for Update, and Delete is for, of course, Delete. REST requires that a client make a request to the server in order to retrieve or modify the data on the server. An HTTP request is generally consisted of an HTTP verb, which defines what kind of operation are we performing, a header, which allows the client to pass along information about the request, a path to the resource, and an optional message body containing the data. There are 4 basic HTTP verbs we use in requests to interact with resources in a REST system. First one is a GET request. GET allows us to get a specific resource by ID or get a collection of resources. POST simply allows us to create a new resource. PUT allows us to update a specific resource. And delete allows us to delete a specific resource. These were only the 4 main HTTP verbs. There are also a few more less known verbs. If you'd like to get a full list of all HTTP actions, download the complete API guide in the description down below. Whenever you make one of the HTTP requests, you'll be greeted with an HTTP status code. Some of the most popular status codes are 200, which means that everything went well, and 404, which means that the requested resource couldn't be found. There are many more HTTP status codes categorized in 5 major categories. Everything that starts with the 1, meaning in 100s, that means that the request was received and something needs to continue. That is an informational response. Everything that starts with 2, or it's in 200s, that means that the request was successfully received. On 300, we have the redirection, 400s are client-side errors, and 500s are server-side errors. This was just a categorization, but if you want to see some more widely used HTTP status codes, they are also included in the complete API guide down below. As we always do on JavaScript Mastery, please allow me to explain everything we've learned so far on a real-world example through API testing. API testing will allow us to check in detail all of the parts of existing APIs. As I've mentioned, APIs have become the center of software development. Luckily, testing them can greatly improve the efficiency and help you deliver software faster than ever. While there are many aspects of API testing, it generally consists of making requests to a single resource or sometimes multiple API endpoints and validating the response, whether for performance, security, functional correctness, or just a status check. Let's check it out in action. For API testing, we'll be using PAW. PAW is a free-to-use API testing tool that allows you to send all kinds of HTTP requests. It allows you to organize and create groups of requests and environment variables for individual projects. Whatever you send or receive, PAW will find the best way to display it. It supports web pages, images, PDFs, and has a full syntax highlighting for most programming languages. PAW knows about your mistakes and warns you when something looks wrong. It makes you avoid common mistakes, such as sending a body in a GET request. In this video, we'll cover all of the features that PAW offers on 2 publicly available APIs. That way, once you create your own API, and remember, the video teaching you how to do that is linked in the description, you'll be able to test them in the same way. So let's go ahead and get started. To start testing your APIs, you can click the link in the description. It's going to be paw.app. On here, as you can see, I already have 2 different APIs that I've been testing before. But in this case, we want to start completely from scratch. So let's go ahead and click this plus icon right here to create a new project. And let's call it JSON_placeholder. Great. In just a few seconds, the project has been created and we can immediately start creating requests. So the API we'll be testing is going to be the JSON placeholder API. Free fake API for testing and prototyping. Let's see what this API offers. We can go to guide, and right here, it's nicely documented that we can get one specific resource or a post, or we can get all of the resources by making a GET request to this specific endpoint. But now, let's really test that out. let's see how it works in the real world. To test this API out, I'm going to copy this URL right here. We can go back to our JSON placeholder project on paw.app, and right here, I'm going to create a new group of requests. Then we can delete this demo request right here by saying delete request. And inside of this group, we can create a new request. We can simply paste the URL right here at the top, and let's call it retrieve all posts, like that. And we can copy that and paste the same thing in the description. This is the simplest request we're gonna make. We don't have to pass any additional headers, queries, body, or auth. We just have to click send. And in less than a second, we got our 200 back. If you watched the video carefully so far, you know that 200 means okay, everything went well. And inside of here, we can actually check out the info of the request we've made. We can see our request headers right here. But what we really want to know more about is going to be the response JSON text. This is the actual data that has been returned from the API. You can see that this is an array of different objects like this. And in paw.app, you can immediately collapse it or uncollapse it and see all the data in a nice readable format. As you can see, the API returned an array consisted of 100 different posts. Each post has the user ID, the ID of the post itself, the title, and the body. Great. So you just learned how to test one specific endpoint. And again, you can document it right here with a description and a name. This seems incredibly simple right now because it was already documented. But if you were to create your own API, then you would have to properly test everything out. But now let's go to our second request, which is creating a post. Right now, we can scroll down and we can already see what we have to do. We can again copy this URL, go back to our API testing, and let's create one more request. We can paste our URL here, and this time we'll be making a post request. In the name, we can say create a post, and we can copy that and paste it in the description as well. But now with the post request, we also have to pass the body of the post itself. So right here, we can pass it as a text, JSON, or a JSON tree. It allows you to pass the values as key and value pairs. So every post has to have a title. Let's say this is my new post, and it also has to have a body. So we can say body, and right here we can say lorem ipsum, and then ... Of course, this was supposed to be a long paragraph. And we also have to pass a user ID, and in this case, let's make that equal to 1. And finally, now that we have this, we can go ahead and press send. This time, we got back to a 1, not 200, which means successfully created. Again, if you haven't already, make sure to download the entire API guide. There, you'll be able to find what all of the HTTP status codes mean. So, as you can see, we will return some JSON back, and the only thing that was added is the ID. Now, this API is just used for testing purposes. So our real post is not going to get added to the list of all the posts. We can go ahead and check that if we make a new request to retrieve all the posts. Let's go ahead and send it again. And as you can notice, it wasn't updated. We can scroll to the bottom and you'll notice that the last post has the user ID of 10 and it's going to be an ID of 100. But that doesn't mean that we haven't created the post successfully. As you can see, we have. But what would happen if we missed some of the important properties? Let's say that we forgot to pass the user ID. I'm going to delete it, delete this here as well, and let's send. As you can see, it was created again, but this time it doesn't have the author. So this might be a bug in your system depending on what you want to do with your application. In my opinion, I would definitely throw an error here because every post has to have an author. With that said, what would happen if we remove the body and the title altogether? We completely forgot to pass the body. Let's click send, and again, this API is not covering it. We only get back the ID, But this definitely shouldn't be the case, because we didn't send any body there. The post shouldn't really exist. So this really shows you the power of what API testing can do. You could prevent all of the unnecessary potential bugs that this is going to cause to your application. Imagine receiving all the posts with different bodies, authors, and titles, and then you receive a few of these without anything. This is surely gonna cause an error in your application, and this is exactly the point of this video, to prevent that from happening. Now, let's scroll a bit more down and let's implement updating a resource. We can again copy this URL right here, go back, and create a new request. We can pass it right here, but this time it's not going to be a GET or a POST request, it's going to be a PUT request, meaning we want to change a specific resource. Inside of the description, we can simply write update a post. I'm going to copy that and paste it right here as well. Finally, we can go to the body and let's this time pass plain JSON and not a JSON3. Basically, what this means is you're simply going to pass it as a JSON object. This is how you would do it inside of your application. So let's simply update a resource with an ID is equal to 1. We're also going to update a title. Let's say the title is, this is a new title. Keep in mind that this is a JSON format, so you have to have double quoted strings around keys and values. We can also update the body, and let's say something like this is a new post body. Great. And finally, let's update the user ID as well. So we can say user ID is equal to 1. And finally, let's send it. As you can see, we got 200 back, which means that the article has been updated successfully. This is the JSON3 that we get back. We can also view it as a plain text, and we can see the headers that were sent as well. The last request we're going to implement is going to be deleting a resource. We simply have to make a delete request to one specific resource. So I'm going to go back and I'm going to create a new request right here. We can paste the URL and change the HTTP verb to delete. Let's also modify the name and the description. We can simply say delete a post, and we can also copy that and paste it in the description. Great. Let's go ahead and send that request. And we have 200 OK. No data was returned, but a 200 means that our article has been deleted. Great. We just tested a CRUD API. If you remember what CRUD stands for, create, read, update, and delete, meaning we can successfully update the database. Again, this is just a test API that is just mocking the actual responses and requests. But if you were doing this to your own API, you would actually be changing and updating the resources in the database. Now, I want to talk a bit about the structure of the URL itself. We always have the HTTPS at the start. Then we have a specific domain we want to go to. But the last part is the most important part. /posts/1. What does that actually mean? And how can you best structure your API endpoints? The REST resource naming guide is my go-to resource for the API naming conventions. The link to this tutorial is going to be down in the description, but I've also included only the most important parts of this entire thing in the complete guide to APIs that's also linked down below. But right now in this video, let's quickly go through this together. I want to point out a few important things. In REST APIs, there is something known as a resource. Anything that's in your database or that you're working with on a server is called a resource, meaning any piece of data. So let me give you a better example. A resource can be a singleton or a collection. For example, customers is a collection resource and customer is a singleton resource. We can identify customers collection using the URI or URL customers. And we can identify a single customer resource using the URI customers and the customer ID. So this is a really important thing that I want to emphasize. You always want to name your resources in a plural form, customers. And then you can say /customers /1, 2, or any kind of customer ID to get the data about a specific customer. If you were paying attention, you could notice that that's already happening. Right here, you can see posts and then one. Same situation, plural of post, and then we want to get a single post. If you want to get all of the posts, then simply do /posts. This is a first really important step. The second important concept is a subcollection of resources, meaning every customer can have a lot of accounts. So how do we access that? It's not going to be /customer1 accounts or something like that. You want to have a structure, /customers, /customer ID, as it was before, and then you simply add the /accounts to that. And then if you want to access a specific account ID, you do it one more time. So /customers, customer ID, and then you can go deeper as you're accessing a deeper part of an object. Great. Let's see a few more best practices. Use nouns to represent resources. I think this is something that's intuitive. It's always going to be accounts, users, customers, posts. You're not going to use verbs. And here are some more important best practices. Consistency is key. Always use /. Do not use trailing / like this. Use hyphens to improve the readability. So if you have something like multiple words together or a sentence, always use dashes in between. Not underscore, not spaces, not camel case. Use hyphens. There we go. The next step said it for me. Do not use underscore. And also always use lowercase letters in the URIs. Do not use file extensions. Adding them simply looks bad and doesn't add any advantage. Never use CRUD function names in URIs. This is something really important and maybe should have been mentioned earlier. As you're starting with the API creation, it might make sense for you to simply call an API endpoint something like create a device management or create a managed device or / get all managed devices. But that's not going to be the case. As you're starting with your API creation process, it might make sense to you to simply call an endpoint something like create managed devices or create a managed device or something like get all managed devices. But that doesn't make a lot of sense. Simply do as we said so far. Follow the structure and always use plural names. And then the HTTP verb is going to say the rest. Of course, if you're making a GET request to / manage devices, then it's going to serve a purpose of getting all devices. But if you're making a POST request to manage devices, then it's going to create a new device. It's important to know that you can have multiples of the same specific endpoint, but if an HTTP verb is different, then the action is going to be completely different. And the last thing on our list is to simply use query components or query parameters. Meaning, if you want to pass some extra information through the URL, then use a question mark and then use key and value pairs. For example, region is equal to USA. If you want to have multiple key value pairs, again, start with a question mark, do the first key and value, and then simply put the and sign in between this and the other key and value pair. This data will get delivered to the server or the frontend, however you're passing the request. We've just covered some of the most important best practices that you can do with APIs. Again, more of this is going to be in the document down below. Let's go to Rapid APIs Hub. The link is going to be down in the description. I'm sure you've seen me use Rapid API in most of my latest videos. They offer hundreds of thousands of APIs that you can build your applications with. APIs like Recipe, unofficial Netflix online global search, Google Play Store, even trip purpose prediction. In this case, let's go ahead and use the COVID-19 data API. That's going to give us a lot of data to test on. We can go to the pricing section, and as you can see, it is completely free for up to 50,000 requests a month. Just go ahead and click subscribe. In my case, I'm already subscribed, so I'm simply going to go back to endpoints. As you can see, Rapid API and PAW in this case look quite similar. They have different requests, explanations for those requests, and they let you know what you're gonna get once you actually make that API request. So, as you can see, this here is incredibly well done. everything is nicely documented and tested. You can easily do this on Rapid API yourself once you create your APIs, and you can start documenting it with PAW. So in this case, let's go ahead and test a few different endpoints. Let's go with totals and get latest total. Get latest total data for the whole world. In this case, we can first go ahead and copy the URL that's on the right side right here. So we can copy the URL, we can go to our PAW, and we can create a new project. Let's call it COVID-19 data. Then we can go into our first request, enter the API call or an API endpoint, and that's going to be a GET request. We can go back and copy this description. We can paste it right here for the name and the description. And the last thing we have to do is we have to provide the headers. We haven't done that so far, but right now we have to do it because this API is not publicly available, meaning you have to create an account and sign up to be able to use it. So in this case, let's go ahead and copy the COVID-19 data Rapid API host right here. And we're going to go under environments, manage, production, and then in here, we can add that as a value. And the variable name is going to be X Rapid API host. And we can do the same thing for our Rapid API key. We can copy it, paste it here, and finally paste the key itself. There we go. Now we can close this and we can actually add those headers. First, we need to add our Rapid API host. So let's paste it here under header name, and under value, just simply right click, go to environment variable, click that, and simply choose X Rapid API host. Now we can repeat the process. Let's go to Rapid API key, paste it under header name, and in here also environment variable, and then Rapid API key. Great. With this, I think we should be ready to make a test request. Let's simply click send, and we got 200 OK with this JSON data right here. This is definitely a long number. In this case, we don't have any commas, so it would be hard to read. But again, you can use this data to create your own front-end application and format it nicely. As you can see, a lot of people have recovered, so that's definitely good. Let's try to make a few more different requests. We can, for example, go to country, and let's go for get latest country data by code. In this case, we're simply going to copy the URL one more time and create a new request right here. Paste it. In this case, we can again copy what they say, get the latest data for a specific country, paste that under name and description, and let's see what data do we have to pass. We have to pass a required parameter, which is the country code. In this case, let's simply copy it, and we have to pass it through request body. So right here, we can simply send it as a JSON, or we can use this JSON tree to simply provide a key and a value pair. The key is going to be code, and the value is going to be IT, which is Italy. Now let's not forget to pass the headers, so we can copy them from our previous response, which is Rapid API host right here. And the other one is going to be Rapid API key. And our values are already stored in environment variables, so we can simply use them like this. Right click, environment variable, click, and then choose it. Now let's see if we can get the cases for Italy. Okay, in this case, we got a 400, so it's good to see that that works as well. But the question is, what is the error? Why didn't this work? And the reason why it didn't work is an incredibly important difference between the post request and a GET request. Right now, we're working with a GET request, and by design, you cannot send any body data through a GET request. You can only do so through a PUT request. So it's not possible to pass the data through the body with a GET request. So what we can do is, instead of passing this through the body, which is impossible, let's pass it through the query. These are query parameters. Through a GET request, you can do what we already learned. you can add a question mark and then provide a key and a value pair. In this case, PAW is going to do that for us, so we can simply say code and then IT. And down below, you should be able to see that it added params right here. Now, if we make this request, you can see we got 200 OK, and we get the cases for Italy: confirmed, recovered, critical, and so on. Great. I'm really glad that this small error occurred, just so we can more clearly explain the difference between the request body and request query. And that was it for this video. I hope that you now have a better understanding of REST, CRUD, HTTP, and APIs in general, as well as how to properly test out the APIs you write or use. Once again, I'd strongly encourage you to save the complete guide to APIs linked in the description down below, so that you can use it as a reference or a reminder later on. Thank you so much for watching, and I'll see you in the next one. Have a wonderful day.